Okay, welcome to the video about solving equations. We're starting with two-step equations, so you've probably shown me or you think you have a good understanding of how to solve equations in general. We'll start with some of these review type ones and then get on to some of the more complicated ones. When you solve equations, remember the goal is to get the variable by itself. And the way we do that is by balancing the equations. If you do something on one side, you have to do it on the other. And undoing. To undo something that's happening to the x, we do the opposite operation. So balancing and undoing. Well, we always undo things. Remember, we do the addition and subtraction first, and then we do any of the multiplication or division second. Sort of the opposite of the way we do order of operations if we're just simplifying an expression. So if we're going to do the opposite of adding 5 onto this x, then we're going to subtract 5 from both sides. And some people like to draw that line up the equal sign. As a reminder, if you do something on one side, you have to do it on the other. So I'm going to do subtract 5 here. This is the balancing part. I have to maintain that sort of teeter-totter aspect. Well, the 5's cancel each other out here. So I'm left with x divided by 2 is equal to 11 minus 5 is 6. And then if the x is being divided by 2, the opposite of division is multiplication. So I'm going to multiply by 2 on both sides. Multiplying by 2 and dividing by 2 cancel. So I'm left with x is equal to 12. If I want to do a quick double check, I just plug in 12 here for x. 12 divided by 2 is 6. 6 plus 5 is 11. So that checks out great. Here, you're probably more comfortable with something looking like this, an equation looking like this. Again, we want to draw that line up where the equal sign is. We're going to do the adding or subtracting first. If we're subtracting 4, the opposite of that is adding 4. Those cancel. 4y is equal to 20. We're going to divide by 4 on both sides so that y is equal to 5. Pretty straightforward one here. Double check is 4 times 5. That's 20 minus 4, 16, so that works out. Never any reason why you should get a problem wrong, because you should always be checking your work. So sometimes we need to combine like terms. So like terms are when you have variables or numbers that need to be combined, and you can combine variables with variables and numbers with numbers. Here the term is 8y and the second term is 3y. Since they both have a y, you can just combine them, and since we have the addition sign here, we're going to combine them by adding. So 8y plus 3y is 11y. That's still equal to 44 on the right hand side. Solve for y. Y and 11 are being multiplied. The opposite of multiplication is division, so y is equal to 4. Still can check my answer. 8 times 4 is 32. 3 times 4 is 12. 32 plus 12 is 44, so that works. Here I have my terms that I can combine on the right-hand side of the equation, or the equal sign. Don't get confused just because it's on the right-hand side. You're still going to use the same processes. Negative 5k plus 13k. Well, negative 5 plus 13, well, that's just 8k equals to negative 32. 8 and k are being multiplied. The opposite of multiplication is division. So k equals negative 32 divided by 8 is negative 4. I can still check this up here. Negative 5 times negative 4 is 20. 13 times negative 4 is 52. That's going to be a negative 52. And so 20 minus 52 is negative 32. So check, that works. So here's where we can start to use the distributive property and combine like terms. So we have to do multiple steps here. Multiple steps. Um, if you do the distributive property, remember that means the 2 goes to the x. Sorry why this keeps happening. And the 2 goes to the 6. So I can rewrite this as 2 times x is 2x, 2 times 6 is 12, and that's equal to 39. We'll combine like terms first. 7x and 2x, they both have x's. I can combine those to 9x plus 12 is equal to 39. I subtract 12 on both sides to try and get the x by itself. 9x is equal to 27. Divide by 9. X is equal to 3. Okay? Still check if I plug in 3 here. 3 plus 6 is 9 times 2 is 18. 3 times 7 is 21. 21 plus 18, that's 39, so that works. Distributive property with the 3, again, don't worry just because it's on the right-hand side. I still have the 3c. Here, I need you to be very careful that this negative is traveling with the 3. So you're multiplying both parts by -3. The operation in front of a number or in front of a term goes with that term. So -3 times 6 is going to be -18. -3 times -2 is positive 6c. Well, I have a 3c and a 6c, so I can combine those to be 9c. Still have minus 18. Get the c by itself, so let's add 18 to both sides. 9c is equal to, let's see, so that's going to be 15, carry on 45, divide by 9, c is equal to 5. Plug it in and check. 2 times 5 is 10, 6 subtract 10 is -4, -4 times -3 is 12, 3 times, so we have 12 on that part. 3 times 5 is 15. 15 plus 12 is 27, so it works. Here we're using the distributive property and using a fraction, distributing the fraction. Don't freak out, it's just a fraction. 1/3 times 9. Well, 1/3 of 9 is just 3 in the D, and 1/3 of 3 is just 1. And that's still equal to 5. Well, here then we just have a very simple one-step equation, -1 on both sides. 3D is equal to 4. Divide by 3. D is equal to 4/3. Or if you prefer, 1 1/3. Or if you prefer, 1.3 repeating. Distributive property here, again, don't forget that -5 distributes through, so we have -3 is equal to 12y. This becomes plus 10y. This becomes plus 35. Combine the y's. -3 is equal to 22y plus 35. If you subtract 35 on both sides, 22y is equal to -38. Oh, I see a mistake. This isn't working out evenly, so I got confused. Hold that thought. Maybe you found the mistake already. A -5 times a -5 times a +2 is going to be a -10y. So 12y minus 10y is only going to be 2y. That's going to work out better. So now when I minus 35 from both sides, the 35's cancel, so I have 2y is equal to -38. This works out better. So now that when I divide by 2, y is equal to 38 divided by 2 is -19. Did you catch your mistake? Did you catch my mistake? All right, now when you have variables on both sides of the equal sign, we have to combine like terms still. But since we're crossing over that equal sign, either this way or this way, you have to do the opposite operation still when you cross over the equal sign. And so if I want to bring, say, this 8x over to the 4x, because I want my x's to be together, this is where it's really helpful to have that line down the middle, then I can just add 8x, sorry, oh, that's annoying, add 8x on both sides. I guess I'm writing too close to that. And the 8x's cancel. And so I have left on this side 7 is equal to 4x plus 8x, that's a plus sign, is 12x minus 17. And I'm going to add 17 on both sides. And this is going to work out nicely because I have 12x is equal to 24. Divide by 12. X is equal to 2. If you want to check this one quickly, 8 times 2 is negative 16, so 7 minus 16 is negative 9, and then 4 times 2 is 8, minus 17 is negative 9, so it's equal to negative 9 both sides, so it works. When you look at an example like number 2 here, you need to be careful about which way you're bringing your variable. I could have easily brought the 4 over to this side by subtracting 4x. If I tried to bring the 5 over to where the 3 is on this side, then I don't have anything left over on the right-hand side. So be careful that you're not leaving one side totally blank. I think the strategy should be bring the variables to one side and the numbers to the other side. In this case, I'm going to add 3m over here so that I have the variables on this side. 8m is equal to 24. Now I can just divide by 8. So that m is equal to 3. So use some strategy, use some planning ahead in trying to bring one variable to one side or the other. So a little bit trickier because now we have fractions, distributive property, and variables on both sides. But I know you can do this. We're still going to distribute the 1/4 like this. I still have 9x subtract 5. 1/4 of 16 is 4x. 1/4 of 60 is 15, right? 60 divided by 4 is 15. I'm going to bring the x over to here. I'm going to minus 4x. Because if I brought it the other way, I could see that I would have a negative. So this way I'm not going to have a negative. 5x minus 5 is equal to 15. Same thing, add 5. 5x is equal to 20. So clearly when you divide by 5, then x is equal to 4. On this one, 2/3. I'm distributing 2/3. Oh, this just doesn't like me. 2/3 of 6. So if you divide 6 into 3 parts and take 2 of them, then you're going to have 4y left. And if you divide 15 into 3 parts and take 2 of them, you're going to have 10. And I still have 8y minus 6. And again, I'll probably minus 4y on this side because I know that cancels the y's here and allows me to have a positive 4y here. Now, if you're feeling sophisticated and you think you can handle doing 2 steps at the same time, I might also add 6 at the same time here. Saves a little space, saves a little time, because what I'm doing is bringing the variables to the left-hand side and the numbers to the right-hand side. So those cancel, so I know I'm just going to have 16 on this side. Divide by 4, y is equal to 4. As you start to get more comfortable as well, you don't have to always show every single step, especially these last ones where you're just dividing by number. Let's see how many more examples we have. Ah, some decimals. Not tricky ones. So again, like we said, distribute, combine like terms, and solve. So many, many steps here. If I'm distributing negative 0.25, that's a quarter. So I want a quarter of 4, which is just 1. And since it's a negative times a positive, it's going to be negative 1. I have my v there. And a quarter of 8, negative times a negative is going to be positive. A quarter of 8 is just going to be 2. 0.5 is a half, so just half of 4 is 2. And then half of negative 2, it's negative, so it's going to be 1v. Might do this on both sides. If I add 1v on both sides, something interesting happens. The v's cancel here, and they cancel here, and I'm just left with 2 is equal to 2. There's no solution in this case. When the variables cancel each other out, you can just say that there is no solution. So that's an interesting example. If you look at this example down here, whoops, I still have my 14. I'm doing 1/5 of j. Well, that's just going to be 1/5 of j. 1/5 of 10, if I divide 10 into 5 parts, that's going to be 2 of them, and a negative times a negative is a positive. 2/5 of 25, well, 25 into 5 parts, and then take 2 of them, that's going to be 10, and then plus 2/5 j. Now, see how this is a negative and this is a positive. So what I might do is add 1/5 j here and add 1/5 j here so that those cancel. I'm going to combine like terms at the same side. I hope you're really paying attention here. 14 and 2 is going to be 16 on this side. I have 10 plus 2/5 and 1/5 is 3/5. J minus 10. We have to rewrite more of this up here. So 16 minus 10 is 4 is equal to 3/5 j. Now, excuse me. The easiest way to deal with this fraction is to multiply by its reciprocal. Okay? Instead of having to divide by 3/5, it just gets tricky here. To get rid of the 3/5, I can multiply this side by 5/3, because that gets rid of the 3/5. 3 times 5 is 15, 5 times 3 is 15, 15/15 is just 1. And all you have to remember is if you do it on one side, you have to do it on the other. So I have to multiply on this side times 5/3. So that cancels these here. I'm left with j on this side. Here I'm just going to do 5 times 4 is 20, 4/1, 3 times 1 is just 3. So I'm going to leave my answer as 20/3. That was a tricky one. This is called multiplying by a reciprocal. So a reciprocal is a fraction flipped over. I think there's 2 more examples. Oh, that's it. Just kidding. Those were the last 2 examples. Good luck. Take your time. We're going to spend a couple days practicing this in class. So see you there.